And we will continue to chomp through this input sequence until either we get to the end or we get to something that passes the filter. And then the next time you call me, I'm going to return complete. So that's where, just to sort of...
Can you just drop down a bit your font size?
Oh, sorry. Yeah.
Yeah.
I can also... Can you still see that at the back? I can do it better. Something like that. Is that about right? A little smaller.
Yeah.
Okay. So the next thing we'll do is select. So select is where you get to change the type of your sequence. So this is going to involve two types, T in and T out, as it were. So T out, if I can type. And in this case, what we want is a function that will take our input type and return the output type. So let's go through the motions again. This is defining, in this case, actually, our loop state is nothing more than just getting hold of the enumerator. You can imagine, have you ever been enumerating something like a list and at the same time try to remove something from that list? You get the sequence modified exception. So you can imagine if you wanted to build that into this scenario, when you call get enumerator, you could take like a hash of the contents of that list, and every time you call move next, you could recalculate the hash, and if it was different, you would know for certain that the list itself had been modified, and you could throw that exception yourself. So this is what I'm saying. This is your opportunity to set up the loop state in the call to get enumerator, if you can map that back. And then move next, you're making use of that state and modifying it to keep your it's like your program counter, really. So back to select. So this is our move next call again. And in this case, we don't need a while true. It's simply if var result equals enumerator, get the next value from it. If that is the end of that, then we return a notification complete of T out. Else we're going to return a notification next of, well, here we apply what's still called predicate, but it's actually a projection. What was I thinking? Oh, I've got value. No, you didn't like that. Somewhere on the line. So our input was T in. So I guess it's actually kind of simpler to read it like that. But everyone can see that, right? What's going on there? So let's just make use of that. We can say for each value between 0 and 10, where that value is exactly divisible by 2, i.e. where it's even, we will project that type into something else. And here we'll just say string value is that. So there we have the even numbers, and it's starting to feel a little bit more like the INUmerable, like the building up to the power that you have with INUmerable. So that is one thing. We can also do this at this point, enumerable in where I divided by 2 is exactly divisible by 2. Plus I, and then we say Q dot for each console right line. Oh, I don't know why each is doing that to me every time. Console right line. And there again, it's starting to look more and more like the enumerable that you're used to. So
This is only because your interface enumerable2 is defining that method, get enumerator.
what actually happens? No.
No.
Did anyone say get enumerator? There is no get enumerator. Right?
In
So-
your interface,
Is where and select?
Sorry?
The where and select
You
are
said
mapping
that.
to your where and select method?
To the compiler, let's come back to the compiler passes again, right? When link was introduced into the language, extension methods were introduced at the same time, and so was a feature called query comprehensions, and this is an example of a query comprehension. So where you see these blue keywords like this, which are contextual keywords, if you use from somewhere else outside of the query, it doesn't go blue like that. So it's a contextual keyword that supports the feature of query comprehensions. And what the compiler will do is transform this in a single pass. It will go from this form back to this form. There is no for each involved here. It's actually a mechanical transformation of the compiler to go from the query comprehension form to the lambda form, which we had before. So in order to get full support for that, there are a minimum standard of operators, a minimum set of operators that you should be defining. Those include select and where. So there's another one. Another one which is a little bit more gnarly. I mean, are we clear on that before I move on? Yeah? Okay, so